Okay, let's start. So we'll continue with precipitation and complexation methods. Last meeting, we discussed first the volumetric precipitometry. So we have this another type of titrimetric method. This is outside kasi the acids and bases. So last time, our discussion revolved around acidimetry and alkalimetry. Now, how about those substances that cannot be considered as an acid nor a base? So dito siya magfo-fall either sa precipitometry or sa complexation method. So from the name itself, precipitometry, the reaction or the process is only possible if the reaction between the analyte and the titrant will result to the formation of the precipitate, either formation of precipitate or cessation of the existing one. We just like our acid-base titration, we also have indicators here that will help us determine the endpoint. So we only have 3, unlike the acid-base titration na masyadong marami. We only have 3, the ferric alum, the potassium chromate, and the adsorption indicators. These 3 are used for volumetric precipitometry, wherein we have 3 types also. So this one is summarized in the table. We have the Mohr, Volhard, and Fahans. The Mohr using the direct titration, so you only have 1 analyte or sample and 1 titrant, which is silver nitrate. And for the indicator, it uses the potassium chromate. Okay? And then for the Volhard, ito yung counterpart niya na residual titration using both actually silver nitrate and the ammonium thiocyanate. And for the indicator, that's the ferric alum. Both Mohr and Volhard methods have red precipitate or red complex as the endpoint. And then lastly, we have the Fahans that uses a different set of indicators. We have the adsorption, tatlong klaseng adsorption indicators tayo nito. And then the endpoint will be green to pink. So tatlo lang yan siya. So nag-end tayo here sa application of precipitation methods. Most likely this one is for the determination of like ions or salt content ng ating pwedeng food, pwedeng pharmaceutical products. Now, let's move on to the complexation methods class. So, asa nato ginagamit ang complexation methods? We use this for metal determination, okay? So, we are concentrating here sa metals for our complexation method, and we use EDTA as the titrant, okay? We only have EDTA here as the titrant, the ethylene diamine tetraacetate. That's the meaning of the EDTA. EDTA class is a chelating agent or a sequestering agent. In the presence of metals, they will form complexes. Okay, mag-form ng complex with the metal. So pag sinabing complex, it's a metal ion that will combine with a molecule that has the ability to donate electrons. So one example again of a substance that is able to donate an electron is the EDTA. Again, it will form a complex with other metals. So if we want to analyze metals, we want to quantify them in a specific sample, then we can use the complexation method. Okay, now I said a while ago that EDTA is a chelating agent. So what is a chelate? A chelate is a combining molecule which contains 2 or more groups na magdo-donate ng electron. So if we're going to like look at the structure or the formula of our EDTA, it actually has a group there, a functional group that has the ability to donate electrons, especially to our metals, again, to form complexes. So let us talk about EDTA first since ito yung ating highlight for the titrant of the complexation method. So when you say EDTA, again, it can react with metal ions to form complexes. And these complexes are water-soluble and stable. Now, what part of the EDTA has the ability to donate electrons? So please take note of this. EDTA has 4 oxygen in its chemical formula as well as meron din siyang 2 nitrogen atoms. Okay? 4 na oxygen and 2 nitrogen atoms. Okay? Okay. Again, 4 and then 4 na oxygen, 2 nitrogen that will make hexadentate molecule. What do you mean by hexadentate molecule? Meron siyang 6 na molecule that has the ability to donate electrons to our metals. However, marami kasi tayong EDTA, no? EDTA pure EDTA lang siya, like ethylene diamine tetraacetic acid siya. Meron din kasing nakasalt. So the disodium EDTA in combination with 2 molecules of sodium is more preferred over the acid form of the EDTA because it is more water soluble than the acid and at the same time it's non-hygroscopic. Okay, so non-hygroscopic means it does not absorb moisture in air. So in the laboratory, I just don't know if you have observed that we have a lot of hygroscopic chemicals like the sodium hydroxide that if you are going to leave them in an open container, magiging liquid siya after some time. So that's hygroscopic. It has the ability to absorb water from the environment. Pero when you say disodium EDTA, it has again the advantage of being non-hygroscopic. So even if it will be exposed in the environment, like you leave them in a table without closure, then okay lang. Hindi siya mag-liquefy. And the disodium EDTA is also very stable. Again, compared to the EDTA lang na free acid. EDTA is ethylene diamine tetraacetic acid. Ayun yung sinasabing free acid form of the EDTA. So again, EDTA class can form complexes with the metal ion. So actually, our medical technologists, meron silang tinatawag na EDTA tube, right? Pagka kumukuha sila ng blood, meron silang tube na maliit. I'm not that sure kung anong color yan kasi naka-color coding ata. Yung tubes nila merong red, merong violet. I'm not that sure kung anong color yung tinatawag nila na EDTA tube. So the tube there has EDTA in it to chelate calcium ions. So calcium ions in the blood, meron yan siyang function for blood clotting. So if they want to preserve the blood for their laboratory procedures without having it na mag-clot, then doon nila ilalagay sa EDTA tube. Yan yung work ni EDTA. Okay? Questions so far? One question. Okay, sige. So moving on, we have the so-called, for complexation titration method, we have the so-called masking, wherein we are going to determine a certain metal even with the presence of another metal. So other metals will be masked class so that they cannot interfere with the determination of that specific metal that we are going to analyze. So again, imamask natin yan siya. Just like the example in the screen, zinc will not interfere with calcium titrations at a pH of 13. So like if you're going to determine the amount of calcium in a given sample, we are going to adjust the pH to 13. And even if zinc is present in the sample also together with calcium, it will not interfere with the analysis. But if the pH is not adjusted to 13, then zinc might interfere with calcium titration, leading to variations in the result. So we will not have an accurate results sa pag-quantify sa calcium in a given sample. So aside from adjusting the pH, we also have other agents that can be used to mask metals for the determination of the other metals. So just like potassium cyanide, this substance is able to mask cobalt, nickel, copper, and zinc. While ammonium fluoride can mask calcium, magnesium, aluminum, and that is to allow titration of zinc. Okay, so again, if we want to analyze zinc and it is like in a sample together with other metals, especially calcium, magnesium, and aluminum, then we may add ammonium fluoride for them not to interfere with the titration process. And then we have triethanolamine that will suppress aluminum EDTA complex. The thioglycol also can be used to inactivate mercury and copper, also for the titration of our zinc. Okay? And lastly, even vitamin C or our ascorbic acid may also be used as a masking agent for certain metals para hindi sila mag-interfere with the titration process. Okay? Again, we call the process of adding these substances or adjusting the pH as masking. Now, just like the acid-base titration and even the precipitation, precipitometry, volumetric precipitometry, we also have direct titration and indirect titration here for the complexation method. So we have first the direct titration. We do this for the determination or analysis of either calcium, magnesium, and zinc. Okay, again, direct titration, we may use this if we want to quantify or analyze the amount of calcium, magnesium, and zinc in a given sample. Okay, so our titrant here is mercuric nitrate, while the indicators, your battery is running low. Yeah. Again, while the indicators, we can use either the hydroxynaphthol blue, the aerochrome black, and the silenol orange. So we did not encounter these indicators sa acid-base titration natin. We have different set of indicators for each type of titration process. Now, how about the residual titration? For residual titration, we also call this one indirect titration, wherein we have the analyte and then it will be added with an excess titrant or volumetric solution. And then the excess volumetric solution will be titrated with another titrant. Okay? So in here, we do residual titrations if we want to quantify aluminum and bismuth compounds or even magnesium. Our one titrant here is the zinc sulfate. Now, how about the indicators? The indicators can either be diphysone and the aerochrome black tea. Okay? So I think ito yung mga kailangan nating malaman about complexation methods. Again, if you want to do that in the laboratory, like you want, example, you have a cosmetic product and you want to identify the amount of metals present in it, then you may do titration using complexation methods. But actually, they prefer using our sophisticated equipment in the laboratory, just like the AAS, the atomic absorption spectrophotometry, wherein it will make our lives easier now kasi we will just introduce a small sample in the machine, and then automatically it will give us the amount of the certain metal that we want to detect and quantify. So just like when you have a lipstick, and then remember, lipsticks contain lead. However, lead is considered a cumulative poison, wherein if we are going to accumulate lead in our body and it happens to reach that certain level for toxicity, then we may experience the toxic effect of lead in the body. So we need to analyze the lipsticks first before using them. And ang ginagawa, i-introduce lang siya sa AAS. That's the machine atomic absorption spectrophotometer. Pero since we don't have that in the laboratory, though other private laboratory companies, meron silang ganito, and even other schools, big schools, also do have the AAS. Pwede na silang diretso na, tayo wala. So, magta-titrate. Doon tayo sa manual titration. So again, it can either be direct or residual titration. Any questions so far with these two, volumetric precipitometry and the complexation method? The same process of doing titration has still using the burette. Your sample will be in the Erlenmeyer flask together with the indicators, and then the titrant will be again added in via the burette, and then we will titrate it until we reach that endpoint, that certain endpoint. So most likely, it's more on change in color, or also sa complexation method, change in color pa rin ito ng solution. Even the volumetric precipitometry, there is still a change in color together with the formation of the precipitate. So ganun pa rin siya. Almost similar lang. It's just that they differ in terms of the analyte. Siyempre, for acidimetry and alkalimetry, we are talking about acids and bases there. For precipitometry, we are going to analyze samples that can produce precipitate na hindi possible yung acidimetry and alkalimetry. And then yung iba, yung complexation method is more on metal determination. So I hope nakuha yan ang difference nilang tatlo. Wala pangutana kay we are going to move on with the problem solving. Siyempre QC, everything ends with a problem solving. Wala, so please take out your calculators there. And yes, you may use your periodic table if kailangan. So number 1, we have here a 200 milligram sample of pure calcium carbonate which was acidified and dissolved in 500 ml solution. So a 50 ml sample required 25 ml of an EDTA solution for titration. Find the molarity of the EDTA solution. The molecular weight of calcium carbonate is 100 grams per mole. Again, you try to read and understand the problem. This is still getting the molarity. Again, this is still getting the molarity. So definitely we are going to use this same formula. And as far as I can remember, we have already discussed this one. I think prelim or early midterms pa yung computation of molarity. So please go back with that if you have your notes and look at the formula I gave you for molarity. Again, we have a 200 milligram sample of pure calcium carbonate was acidified and dissolved in 500 ml of solution. A 50 ml sample required 25 ml of an EDTA solution for titration. Find the molarity of the EDTA solution. Molecular weight of the calcium carbonate is 100 grams per mole. Wait lang. Wait lang ha.
Paano pa naman? Buuin. Kung ganito naman, ito pa yan. Uy, hati ako. Ikutan ako na ako. Galing mo. Hindi mo mo pibigyan.
Let's mute that. Okay. I have my pen now, so let's try to answer this class. Thus, we will still use the same formula, molarity. Oh. Hindi siya nangyari sa aking pen. Molarity is equal to the moles of solute over liter of solution. Ito pa rin. Pero when we are going to look at the problem, we don't have moles there. So we cannot easily compute the molarity. But itong liter of solution, it's the liter of the titrant. Okay? It's the liter of the titrant, the volume of the titrant used during titration. And in this case, that is the EDTA. So that's 25 ml. You just have to convert that to liters. So let's start with that. 25 ml. Our conversion factor is, in 1 liter, we have 1,000 ml. There's my... So cancel ml, ml. 25 divided by 1,000 is 0.025. 0.025 liters. So that's what we are going to use, 0.025 liters. Now, let's look at the number of moles. Accordingly, we have 200 milligrams of pure calcium carbonate. Let's convert this first into grams kasi we don't really use milligrams in the computation. It will be much easier if we are going to convert this first. So, sa isang gram class, we have 1,000 milligrams. Cancel this. 200 divided by 1,000 is 0.2 grams. So anong sabi? Itong 0.2 grams of calcium carbonate was acidified and dissolved in 500 ml of solution. Again, ang 0.2 grams na sample ay dinisolve sa 500 ml. But take note that during titration, only 50 ml of the sample was used. Therefore, what you're going to do here is we will have ratio and proportion kasi not the whole 500 ml was used. Therefore, not all the 0.2 grams was also used. So we will see how much of the calcium carbonate is included here in the 50 ml. That is the reason why I am doing a cross multiplication, ratio and proportion. So cross tayo, 500 ml X is equal to 0.2 grams times 50 ml. Okay, so 500 ml X is equal to 0.2 times 50 is 25 grams times liter. Ay, no, times ml pala. Sorry. Let me erase this first. Grams times ml. Divide both sides by 500 ml. Cancel this, cancel the ml. So the x here is 25 divided by 500 is 0.0. Ay, hindi mo na siya mo-argue. 0.05 grams. So class, ito lang yung ginamit during titration. This was the amount of calcium carbonate that was included in the 50 ml sample used during, again, titration. Now, how about the number of moles? We are not yet done kasi we cannot use grams here in the computation. Therefore, we are going to convert this to mole first. Now, how do we do that? Remember this formula. Mole is equal to the weight of the substance divided by its molecular weight. So the weight of the substance here, we have computed that already. That's 0.05 grams. Divided by the molecular weight, it's already given. Look at the screen. That's 100 grams per mole. Okay? So cancel the grams. You will be left with moles. 0.05 divided by 100 is 0.00005 moles. Sorry. This is 0.00123. No, nasobrahan pala ng 0. Yan na pala siya. 0.0005 mole. I hope you can still see it. I hope also na nasundan yon. So since meron na tayong moles, we can proceed now in the computation of molarity. So 0.0005 mole divided by 0.025 is 0.02 moles per liter, or this is equivalent to 0.02 capital letter M. So this is now the answer, class. Ay, asa na? .2. Ay! Ano ba na siya? Sorry. Let me... Ano? Masig 0.5 akong gibutang. 0.2, no? Ulit. This is 10. Saan nireklamo ba? Patakara po sulat. So this is 10. So 10 divided by 500. This is 0.02 pala, sorry. This is... So muka sa 10. 0.2 times 50. 10 divided by 500. 500, no? 500. 0.02 pala ito, class. So this one should be 0.02 also. Yeah. 0.02 divided by 100 pala ito. So 2 lang pala ito. 2. This is 2 here. Ayan. So 0.02 din yung gagamitan natin dito. Ay, 0.0002 divided by 0.025. 0.002 divided by 0.025. Ito na, let me check sa taas. 0.025. 0.08. Let me delete this. Ay, ito din pala. So this is 0.08 mole per liter or 0.08 molar. So this is the answer, class, for the molarity of the EDTA solution. Do not be confused, ha, kasi remember, the moles is supposedly for the calcium carbonate, right? And this one is for the EDTA. But remember, in titration, class, we have the so-called equivalence point. It's the point wherein equal amount of the analyte has also reacted with the titrant. So definitely, the molarity of the analyte can also be the molarity of the titrant. So therefore, this is for the molarity of EDTA also 0.08 moles per liter or 0.08 molar. Okay? Questions or clarifications about this? Do not directly compute, ha, kasi baka nagdiretso-diretso na kayo compute for the molarity. I-understand nyo muna yung problem. So kaya binasa ko ito kanina, 'di ba, sabi ko, this sample was first dissolved here, but during titration, only 50 ml was used. So that is the reason why we did cross multiplication first, or like ratio and proportion, para accurate yung amount of the sample used during the titration process. Okay, clarifications? When you say analyte, that's the sample. That's the sample that we are like analyzing during the titration process. Now, the titrant is the standard solution or the volumetric solution that is added via a burette. Yan yung solution na nilalagay sa burette and dinadagdag doon sa sample mo. So most likely the sample is in the Erlenmeyer flask together with the endpoint. Yan yung pagkakaiba ni analyte and ni titrant. Did I answer your question? Or nalibog gihapon? Again, si analyte is our sample. Si titrant is the standard solution used during the titration process. Okay? Let me delete the writings on the screen. And let's try to solve this. Kamu na sad. The last naman ni sa inyong class participation. How many grams of disodium ethylene diamine tetraacetate, the molecular weight is 370, is required to prepare 250 ml of a 0.025 molar solution? Actually, this is just a direct method of getting the concentration. It is not, this is not done through titration. You just have to determine the amount in grams of the EDTA to be used in order for you to be able to prepare this solution. 250 ml ang volume and 0.025 molar ang concentration. Sige, you try. I'll wait for your answers in the chat box. Ano naman may question mark. Now, tanong na to ang uban be, ang dili mo tubag, katulog na tingali. Wala rin maghabol. Mauna ni. Kadua-duha. Okay na. Mauna ni tanan. Well, let me see. Okay. Sige, let's see. So, how many grams of disodium ethylene diamine tetraacetate? Molecular weight is 370 is required to prepare 250 ml of 0.025 molar solution. So you will still go back with the original formula. This one, molarity is equal to moles per liter. Molarity is given, hindi ako mag-derive ng formula ha, substitute ko lang. 0.025 and let me use moles per liter para mas madali mag-cancel. Mole is not given, so definitely ito yung hinahanap natin. The liters of solution though not given, but we can convert 250 ml times sa isang litro we have 1,000 ml. Cancel this. So this is 0.25 liters. Ayan. So na-substitute ko na lahat ng given dyan. Cross multiply. Baba mo si moles. We have here 0.025 moles per liter times 0.25 liters. Cancel this. 0.25 times 0.025. This one is 0.00625 moles. Ito yung number of moles. Now remember the formula, moles is equal to weight of the substance divided by its molecular weight. The moles has already been computed, 0.0625 moles. And then we are looking, right, for the weight of the substance in grams. The molecular weight is given in the problem. That's 370 grams per mole. Just like with the previous one, cross multiply. Baba mo si weight, 0.00625 mole times 370 grams per mole. Cancel this. May iwan ay grams. So times 370. Itong 0.0625. The correct answer is 2.31 grams. So ito yung amount in grams of the EDTA required na i-dissolve mo para makuha mo yung concentration na 0.025 molar and then ang kanyang volume ay 250 ml. Anyway, did I miss something in the problem? Mole, 0.025 to 50. 0.025 times 0.25 times 370. It's 2.31. Saan galing yung 9.25? Anong nangyari dyan? Yan naman na. Isa pa daw. Direct. Si direct. Kulang ng isa ka zero. Ah, okay. Gimultiply niyo diretso. Saan yung gimultiply? Mole pa lang yan siya. Ha? Grams per mole. Grams per mole. You cannot cancel the unit there pag i-direction niyo. Bawi ang galaxy. Okay. Sige, next life. An EDTA solution is standardized against high purity calcium carbonate by dissolving 0.3982 grams of calcium carbonate in hydrochloric acid, adjusting the pH to 10 with ammoniacal buffer ammoniacal buffer, and titrating. If 38.26 ml was required for the titration, what is the molarity of the EDTA? Tapos kayong problem, tanong lang siya molarity class sa EDTA. So, ang ginamit sa pag-titrate sa EDTA is the calcium carbonate. So, in titrating, 0.3982 grams of calcium carbonate was used and the EDTA used was 38.26 ml. So, you try to solve for the molarity of the EDTA. Lahi mo mag-answer. So, i-check daw, i-check. Hindi na matulog yung anong oras na. Mag-send ako question mark. But sure. Wala na. Wala na tanan. Sige daw. Molarity pa rin tayo ha. Molarity is moles per liter. So wala tayong moles dito but we have the amount of the substance used. That's 0.3982. So mole is equal to weight of the substance divided by its molecular weight. Again, that's 0.3982 grams. The molecular weight for calcium carbonate, we have calcium, carbon, and oxygen. 113 times, this is 40, this is 12, this is 16, so that's 48. Oh, yeah, 100. 100 grams per mole. So this is 100 grams per mole. Cancel the grams. The mole here is 0.3982 divided by 100. That's 0.003982 mole. Okay, so we have 0.003982 mole divided by how much was used? 38.26. 38.26 ml times isang litro, we have 1,000 ml. So this is 38.26 divided by 1,000. I-calculate. Excuse me. 0.03826 liters. So yan yung gagamitin natin dito. Okay, so let's divide 0.00398 divided by 0.00, ay, isang 0 pala. 0.03826. The correct answer. 0. Let me round this off na automatically to 2 decimal places. 0.10 moles per liter or 0.10 capital letter M. So that is now the molarity of our ENTA. Sige, so tama, 0.10. What happened to the answers of the others? Bakit hindi 0.10? Saan kayo nagkamali? I hope na recognize niyo dyan sa process. Saan banda kayo nagkamali, class? Yeah, any question sa problem na ito? Wala yung pangutana. Oh, this is the last one. Do you have questions? I'll be giving you an activity. I mean, problem that you can practice. Sa pag-type lang. Sa pag-type na dito. Questions about the problem solving? Baka may gusto kayong i-clarify. Example, ganito. What volume in milliliters is required to make 0.05 molar calcium carbonate if 0.8 grams of it will be used during the preparation? Sige daw. If, kayo muna. Ano yung question? Bagangan na tatong sample problem. Kayo muna and then let's check. Eleven magano, sir. Check na ulit before ko magano. ML ha, ML. Liter? ML ang hinahanap ko ha. Sige. So let's try to solve this. So we have here volume ang hinahanap. We have the molarity and then we have the weight of the substance. So in this case, if liter ang hinahanap, I mean volume, you have to start with this one class. Yung conversion ng mole to conversion of weight into moles. So this is mole is equal to, that's 8 grams. This is calcium carbonate. This is the same substance kanina. So hindi ko na ipakita yung molecular weight HADS is automatically 100 grams per mole. Again, look at the previous problem. We have the same substance. So 100 grams per mole pa rin yun. 8 divided by 100 is 0.08 mole. Okay, ay, anong 8? 0.8. 0.8 divided by 100. 0. Ilang 0 ang kulang ko? Dalawa. At isa lang pala. Ay, kulang. 1, 2, 3. So this is the mole. Now, pag meron na tayong mole, we will be using the original formula. Molarity is equal to moles per liter. So we have here, wait lang ha. Molarity is 0.05 moles per liter. Let's just use that para makancel natin ang unit. And then yung mole na na-compute, 0.008 mole. And then liter sa baba. Cross multiply, you will have 0.008 mole here. Sa kabila, you will have 0.05 moles per liter times the liter na hinahanap natin. Now, divide both sides by 0.05 moles per liter para makancel natin ito. Ang maiwan sa kabila, yung hinahanap natin. We can also cancel the moles. So, 0.008 divided by 0.05 is 0.16 liters. Kaya lang, yung question ko kasi volume in milliliters. So 0.16 liters times, sa isang litro, meron tayong 1,000 ml. Cancel the liters. So this is times 1,000. The correct answer is 160 ml. So kailangan ang solution ay 160 ml para ma-achieve natin yung 0.05 na molarity kung ang gagamitin na weight of the sample is 0.8. Okay? So again, that's 160 ml. Okay, wait lang ha. Pakicopy lang muna. Wait lang. Dumating.